Okay, so let's kick things off. So I think most of you know me, but I'm Dan Maynard. I'm really excited today to introduce you all, welcome you to our People in Interlab External Seminar Series. So for those of you who have only been to a few of these, we have these every couple months, and the idea is to bring in people who are working particularly in biodiversity conservation action, have some sort of applied avenue from all across, whether it's academia or NGOs or government organizations, to really give a flavor for how people are putting the sort of evidence that maybe we gather into practice. I actually don't know, maybe we could, afterwards I'll chat and I'll let you know when the next one is. So just to give you a heads up on the future ones. So I'm really excited today to introduce William Morgan. So William is a postdoctoral researcher at the University of Cambridge with both the agroecology and the conservation evidence groups. Before that, he earned his undergraduate in Exeter in biological sciences, then went on to do a master's also from Exeter in biodiversity. He did his PhD at Aberdeen with Xavier Lambin, using species translocations as a tool for studying range expansions. He joined the Conservation Science Group at Cambridge in 2020 and recently moved over to the Agroecology Group. Today, he'll be talking sort of a broad overview of his experience across all of those different appointments, looking at the challenges of using evidence for action in conservation and how this can inform biodiversity policy. So a big warm welcome to William.
Thanks very much. I'm just going to start a timer here so that I can keep track. So this is a Boeing Model 299, the Flying Fortress. At the time, it was the most sophisticated and largest aeroplane of the day. Turns out, though, that it was very difficult to fly and quite easy to crash. Investigating the reasons for the crashes revealed some problems. So pilots were muddling two very similar looking levers that were placed next to each other. One of them operated the landing gear and the other one operated the wing flaps. So you can imagine that pulling the wrong one at the wrong time can lead to disastrous consequences. But the solution is quite simple. Add a little wheel-shaped icon to one of the levers and add a little wedge-shaped icon to the other lever. This kind of solved the problem and it became routine practice. This wasn't the only challenge, though, to flying this plane, and to help with the complexity, they developed and implemented a series of checklists, and these are now required on all aircraft. So this process of reviewing, reflecting, and changing practices led to enormous improvements in safety in aviation. So the total number of annual fatalities has tumbled between 5- and 10-fold since the 1970s, despite enormous increases in the number of people flying. Medicine has undergone a similar revolution in the use of evidence over the years. So in 2015, there was a study in a hospital in Spain that found that establishing an evidence-based practice unit led to significant decreases in patient mortality and duration of stay in hospital. Then in 2023, there was a systematic review that found 600 studies looking at evidence-based practice, and they found that there were improved patient outcomes and improved return on investment for healthcare systems. So both of these sectors have got to a stage where it's kind of unthinkable not to use evidence in your decision making. And as a result of that, people are living longer, healthier lives. And we think that's the time, well, we think that the time is now to do the same in conservation. So my name's William Morgan. I'm a postdoc at the University of Cambridge. I've been working on the Conservation Evidence Project for about the last 6 years now, partly, as Dan mentioned, in the Conservation Science Group, and more recently as part of the Agroecology Group. Today, we're going to have a little bit of a brief history of the Conservation Evidence Project and evidence-based conservation more generally, look at some of those gaps and biases in the evidence base, and what we know about the effectiveness of conservation actions. We're then going to look a little bit about accelerating evidence synthesis with the help of AI, and then about how we go about embedding evidence in conservation policy and practice. So the field of evidence-based conservation kind of developed in the early 2000s, following the publication of a few big perspective pieces calling for kind of an evidence revolution. The main concern at the time was that current practices weren't as effective as they could be, and that they were too reliant on, and I quote, anecdote and myth. In the years that followed, there were massive advances in generating primary evidence on conservation impacts. synthesizing existing studies and developing new tools and resources for embedding evidence in decisions. Fast forward to the 2020s, and evidence is a key part of global efforts to reverse trends in biodiversity declines, and evidence is a key part of the global biodiversity framework. So one of the dedicated evidence synthesis organizations over these years has been Conservation Evidence, of which I'm a part. And our mission is to make evidence for conservation easy to access and easy to understand. We basically work by searching the whole of the literature for studies that have tested the effects of conservation actions for any habitat type, any species in any part of the world. So far, we've screened well over 1 million scientific publications and summarized the available evidence for over 4,000 conservation actions. We've got a slightly different approach to doing things than the standard systematic review methodology, and so I just wanted to kind of walk you through our process. We basically start, and it's a process that we call discipline-wide evidence synthesis, discipline-wide searching, and subject-wide evidence synthesis. So we essentially start by finding or highlighting all of the publications that exist out there that might contain relevant information from us. We go to one of those journals, we start at volume 1, issue 1, and we read every single title and abstract of all of the papers that that journal has published. We've got a very broad inclusion criteria. As I said, it's all of the studies that have tested any conservation action in any context. So what we're doing while we're reading those titles and abstracts is either excluding things that don't test actions, or if it does test an action, we're filing that study away in a kind of topic-specific folder. So those might be particular species groups, it might be particular habitats. The thinking behind this is that you only have to search each journal once, and then you never have to go back and look at it again. So it kind of front loads the effort a lot, because you've got to put in a lot of effort before you even get started. But over time, it should be much more efficient because you never have to visit again any of those journals. So we've searched our titles and abstracts, we've been categorizing things and putting them away in folders ready to be used. When we get the funding to actually tackle one of these topics, we basically assemble a panel of experts. So these could be a group of people that are experts in bee conservation. And co-creating with them, we develop a list of potential actions that you could do to conserve bees. We then go to our folder where all of our studies that looked at bees are held, and we start pulling out those studies and we summarize the key results and we organize them based on the action that they've tested. And once you've done all that, you've got what we call a global synopsis. So we've done quite a few now, and a few more were even published this year. So we've got new ones out this year on vegetation conservation in inland aquatic habitats, fish conservation in inland habitats, and even ditch management. But there's still gaps, and you'll see from the years that things were published, we start going back. There's a lot of updating that needs to be done as well. Anyone that's worked in evidence synthesis will know it's a slow process. It takes a very long time. I thought I'd just take the opportunity to give you a very short tour of the website. I think we find that even people that know about the website sometimes haven't visited it or don't really know actually what's there. So I thought I'd just take the opportunity. So this is our website, conservationevidence.com. You can see along the top that you can explore based on the studies themselves, based on the synopses, so what we were just sort of talking about there, or as I've selected here, based on the actual actions that were tested. So if you scroll down a little bit, you'll start to see a list of conservation actions. You can see the number of studies that have tested them, and those little category icons tell you the sort of the conservation target that they are associated with. If you select one of those actions, you're given an action page. So here we've got install wildlife warning reflectors along roads. We've got 15 studies that tested that action, bit of background information about what we actually mean by the name of the action. And then we provide this little map here to just kind of show you very briefly the geographic spread of the studies that have done that. Scroll down a bit more and you've got set key messages. So this really tells you how many studies there were, where were they carried out, what kind of study designs did they use, and what were the really main results that they found based on these different, split out by different outcome types. and scroll down further still, and you get to the kind of almost what you might think of as data points that are in this database. So these are roughly 200-word summaries, narrative summaries of the findings of the paper. And they're written in a very standardized format. So they all start by telling you what the study design was, when it was done, what kind of habitat and where. And then you've got the main results with quantitative results pulled out. And then you've got a brief description of how the action was implemented and how the data was collected. So it's all there, it's free to use, feel free to explore. A word of warning, if you use our search functionality, it's not like Googling, it's a little more primitive than that. So start with simple single word searches and you might find things. Don't use anything too complicated or it will get confused.
I've heard Australia instead of Australia. Second line there.
I will immediately inform the team and we'll get that fixed. Where is that?
Underlined in green, Australia.
Yeah.
3 were in Australia.
Australia? You've not been to Australia?
No, I haven't.
So we proudly kind of state that we've gathered evidence for over 4,000 actions. But if you spend time exploring the website, you'll see that lots of those actions don't actually have any studies associated with them. So this is where working with our panel of experts, we've said, oh, you could do this for reptiles, say. We've gone out into the literature and we haven't actually found any studies that have tested it. So there's gaps, there's biases. And we worked with a really great undergraduate student a couple of years ago who explored the gaps and biases in our reptile synopsis. So I joined the team back in 2020 working on this global synopsis for reptiles. At that point, I think we'd searched nearly 300 journals, over 700,000 papers, 6 report series. All in all, we summarized 707 publications for this synopsis. But there are gaps in the evidence. Many of them are the typical gaps that you would expect to see. Lots of studies being done in North America, in UK and Europe, Australia, very few studies being done in Africa, in many of the places that have huge reptile biodiversity. We did find, somewhat encouragingly, the countries with more reptile species do tend to have more studies. So that is kind of, it sort of makes sense. It's kind of what you would expect. But there are, there's clearly a lot we don't know about how to conserve reptiles in lots of parts of the world. We also looked at the taxonomic biases. So 1% of our studies were for rhynchocephalians. And that was 8 studies per species. So for bonus points, does anyone know the one species of rhynchocephalian? Give you a clue. It looks like this. Anyone going to be brave? Yes, exactly. Tuatara, yeah. So this is the only rhynchocephalian left in the world. It's not a lizard. It's a completely separate order of reptiles. And this lives in islands off New Zealand and would have been on mainland New Zealand as well. And I think they are trying to get it back. But it was around about 65 million years ago and is basically unchanged since. So it's kind of amazing. Next up, 5% of studies were on crocodilians, 50% on turtles and tortoises. There's not that many species of those, so you're already over one study per species on average. And then the least, 50% of our studies were on squamata, and because it's such a speciose group, that's less than 0.1 study per species in the group. So the top 10 studied species were all from the turtles and tortoises. Lots of stuff on loggerhead turtles, green turtles, lots of people moving sea turtle eggs around beaches. It's a very common thing for people to do. And it turns out nobody studies amphisbaenians. I will happily admit I've not heard of an amphisbaenian before I started this work, but it's another one of the squamates. So squamates is your lizards, snakes, and amphisbaenians, the worm lizards. They're very strange looking things. We also looked at the threat status of species, so looking at how many studies there were per species and whether the threat status of that species affected it. So as you might expect, the data deficient species the least number of studies. This is the IUCN classification. So those that have not yet been assessed or been assessed as data deficient, fewest. We have the most studies for the least concerned and near threatened species, and fewer studies for the vulnerable, endangered and critically endangered species. So again, it's this same story. We are severely lacking evidence for some of the most threatened species, particularly when you consider that data deficient species tend to be predicted to be more likely to be on the threatened and vulnerable side of things than the least concerned side. So there's a lot to do. There's a lot we need to do in expanding the evidence base, directing the research effort to those species and locations that are currently understudied. So we've talked about the spread of the evidence, both geographic and taxonomic, but what does the evidence tell us about the effectiveness of conservation interventions? So the eagle-eyed among you will have noticed, and I showed this earlier, that we have this effectiveness category here. So this action has been judged to be likely to be beneficial. But what does this mean, and how do we decide what the effectiveness category is? So we basically have given our actions scores in terms of the benefits, the harms, and then the certainty. And depending on the combination of those three scores determines the effectiveness category that it falls onto. Beneficial through to trade-offs, through to unknown, through to likely to be ineffective or harmful. Now, historically, the evidence for each action has been assessed by a panel of experts. They read through all of the study summaries within an action, and they give an overall score for the benefits and the harms and the certainty. Harms being unintended harms to your target species. So if we were thinking about reptiles, it would be harms of this action to reptiles. And then certainty is thinking about things like the rigor of the study designs, the geographic coverage, taxonomic diversity. There's quite a lot to think about. The approach makes use of the fact that groups of experts tend to give better judgments than a single expert. We make use of this through a modified Delphi method. So experts provide an independent score anonymously. They then get to see each other's scores. They get to comment. They get to rescore if they want to, or they get to kind of argue their case for why their score's right. So this is what the database in its current form looks like in terms of effectiveness. So the most common is unknown effectiveness. And unsurprising based on what we said. This is quite an encouraging story. I think that clearly the most actions that we have enough evidence for have been judged to be likely to be beneficial, certainly more so than likely to be ineffective or harmful. I mean, you know, you have to take these things with a pinch of salt. There must be huge publication biases, huge incentives to publish the things that work and not so much the things that don't work. There's lots we could talk about that around funding mechanisms and all that kind of thing. But anyway, it's at least it's not this being the biggest bar. But there are problems with our approach to scoring, with our historical approach. The main two, I would say, being that it's time consuming and static. So what I mean by that is that it just takes a long time, and you're asking a lot of people to spend time reading through all of that evidence and to score. I did the scoring for the terrestrial mammals synopsis shortly after I joined the team, and it wasn't really my job, so I was kind of doing it in the evening, and it took a long time. It's very hard. The more studies you add, it's very hard to hold all that information in your head, and honestly, it's difficult not to just kind of slowly slide into vote counting and being like, oh, well, 10 found that it was good. And yeah, so it's difficult to do. It's also static. So what I mean by that is we can't really add an extra piece of evidence. If we do add one more study, we have to rescore the whole lot because the score is for the collective of the studies. So we are coming up with a new, exciting, dynamic approach to scoring. This is all kind of work in progress. So if anyone is taking pictures, then we appreciate not sharing this bit just at the moment. So to overcome those problems I just talked about, this process will shift the scoring to the level of the individual study. And then we'll be combining all of the studies to give an overall score. The advantage being that scores can be updated as new evidence is added, and you can actually calculate effectiveness scores for a user-defined set of studies. Maybe you're just interested in temperate ecosystems. Maybe you're just interested in snakes and you don't really care about lizards. So we can suddenly start catering to a lot more questions. So let's just have a brief kind of canter through this process. So for each study, we need to know the benefits, the harms, and what we call the weight of evidence. So benefits, we score between a 0 and 100, and we use this kind of semi-quantitative kind of guideline. You're providing a score that's going to fall into one of these three categories, from no to some to substantial benefits. We do the same with harms, though the threshold for harms is a little lower than the threshold for benefits. So we've got no harms all the way through to extreme harms. And we've done a little bit of inter-rater reliability testing on this stuff for benefits and harms. And so far, things are looking pretty positive in terms of we get pretty good agreement. We still very much would like to be in a situation where we're gathering multiple scores for studies rather than just relying on one person scoring everything. So then we need to tackle this idea of weight of evidence. So this is made up of two different components. The first is this concept of reliability. So we're providing a score between 0 and 1, which kind of tries to get across the rigor and the quality of the study design and the appropriateness of that design for assessing effectiveness. This builds on some work by a guy Alec Christie did, who was part of the group a few years ago, where he did some simulation work looking at how study design impacts on the accuracy of your predictions. So he basically found that more rigorous designs are more accurate in finding in their estimates of effect sizes. So we use that to basically guide our scoring from very, very simple designs through to slightly more sophisticated, through to your before-after control studies and your randomized designs, which are much more rigorous. The other aspect of weight of evidence is something that we've sort of made up, but which is this idea of the relevance of the outcome for assessing effectiveness. Now, we tend to, so as an example, you could imagine a study that estimates hedgehog road mortality with and without wildlife tunnels under roads, versus a study that estimates abundance trends of hedgehogs with and without wildlife tunnels. It's easier to see how the estimates of abundance trends are going to give you more information than the estimates of survival. So really thinking about like what's that causal chain between the thing that you're measuring and the thing that you actually care about, which is probably things like local persistence or diversity of a community. So again, we provide higher scores for abundance and community metrics, lower scores for more kind of distant results. And just very briefly and short, we take those scores, we take a weighted average. So we've got our benefits and the weight we're giving to that study. So we take a weighted average for the benefits, the same for the harms. And then certainty is a little more complicated. As we have this idea that there's a cumulative weight of evidence, you gradually build up more and more weight as you add studies, and that's going to there's going to be some asymptotic function whereby your certainty is increasing quite quickly to start with, and then it's kind of leveling out, and eventually you sort of reach a point where you're feeling pretty certain. We can talk more about that if people want, but so we're trialing this new approach as part of an EU Horizon project that I'm a part of called RESPOL, which Restoring Pollinators, if you were wondering. So we're going to update we are updating our bee synopsis, which was actually the first one that we produced back in 2010. And we're updating it all the way to 2018. So already it's going to be a little out of date before we finish, but we can talk about that later. But anyway, it's better than nothing. So I've summarized all the evidence that we found for bees between 2010 and 2018. And here's what it says. We calculated the effectiveness scores. So again, it's that same story. Unknown effectiveness is the most common. Though we do seem to have quite a few more ineffective actions for bees than we had across the whole of our database. I should note, though, this is ineffective but not harmful. We didn't really find any significant levels of unintended harm from any of the actions. It was more just actions not really having any impact on bees.
So, sorry, the unknown effectiveness problem, that's not papers that haven't been assessed. It's just papers where the conclusion wasn't clear. Is that right?
So this is the number of actions that we've defined.
Okay.
And so so some of these will be because they've got no studies in them at all.
Right.
Some of them will be that they've got a very small number of studies, or a few studies that have been given a very low weighting, basically. Yeah. So let's take a look at what some of those actions are. So beneficial actions for bees. Things that you might expect: planting nectar and wildflower strips, reducing management intensity on permanent grasslands, restoring or creating grasslands and savannas. All of the evidence suggests beneficial, which is good. Those are all things that people do and people think should work. Things that were found to be ineffective. So rather than planting nectar flower mixtures, planting grass buffer strips, didn't really find any effects on bees. Reducing grazing intensity on grassland by reducing stocking density, interestingly, didn't really find any positive effects. And providing set-aside areas in farmland. I think it's important to say this is not to say that those things couldn't be effective, and that there isn't reason to think that if done in the right way, they could have benefits for bees. It's to say that from the evidence that we found, none of the studies were able to show kind of substantial, significant positive effects for bees. And then what about those unknowns? So we've got a few that things like retaining cover vegetation with perennial croplands. My guess is that if we were able to update to 2026, we would find that some of these were shifting out of the unknown effectiveness into having an actual answer. That's just my hunch. So the nice thing about this new approach to scoring, as I've sort of hinted at, is that we can calculate effectiveness scores for any set of studies that we want. We're just really beginning to think about how we can leverage this new sort of capability, but I think some obvious areas to explore are going to be kind of geographic spread, taxonomic spread. And so here, just for kind of demonstration purposes, here are the studies grouped by the continent. So we can see beyond just those geographic biases and where the evidence is, to see the variation in the effectiveness of those studies. And then zooming into Europe and splitting out by countries. This obviously jumped out. It's slightly intriguing, where it is that we've got lots of evidence coming from the UK, but overall studies weren't found to be particularly effective. So again, zooming into the UK and looking at the spatial spread of those. There's really this cluster of studies down here that didn't seem to positively impact on bees, which is interesting. And we seem to be doing quite well in the Cambridgeshire area. Now, this isn't to say that these were. This is not me saying that bad studies were carried out, or that these studies didn't, or these conservation projects, if that's what they were part of, didn't achieve what they wanted to achieve. Simply to say that the effects that we found for bees weren't significantly positive. But I think it's time to address the elephant in the room. We've talked about it a bit already, but there's just the fact of how behind the current, behind we are in assessing this evidence. Like I said, we're updating things to 2020, 2021, if we're lucky. We're already in 2026. We're constantly running, and unlike the Red Queen, we are falling behind. We're not even managing to keep up. So we've already invested about 75 person-years of time into developing conservation evidence database. In short, it just takes too long. So we've been asking the question, as I think everyone in the world has been asking the question in the last couple of years, can this new generation of AI models help? Can it help us overcome this limitation? So we're working with researchers in the computer sciences department to try and answer that question. And the goal is to develop a robust, transparent, end-to-end pipeline that allows us to find evidence from a known source of studies, evaluate whether that evidence meets our inclusion criteria, categorize it, and extract key results. So if we just go back to our workflow that I kind of showed you, you can see how it kind of can slot quite nicely into this process that we're sort of already using. So the first challenge is finding the papers. And we've been working with the Office for Scholarly Communications at the University Library. We've actually managed to convince 11 of the big publishers to give us access to their full texts. It's been much harder than people expected, even once the agreements were in place. They all have very different systems, very different ways of integrating and gathering the data. It comes in different formats. It's been a real headache. But so far, I think we've downloaded about 15 million full texts, about 10 million of those being closed access. So yeah, huge thanks to particularly James Caldwell, who works at the University Library. It's something that we just could not have done without them. So the idea is once you've got that known database of literature, you're then using essentially a suite of ever larger models to carry out more and more complicated tasks. So first of all, you're ranking and ordering using title and abstracts. Then you're assessing with a larger model on title and abstracts, and then you're going towards full text and starting to extract. We can talk more about this if people are interested at the end. And then I just wanted to show this. So this is kind of cool. This is a video showing the process that one of these models is going through to find potentially relevant papers. So it's a multi-dimensional space that has been squashed down into 3 dimensions, so we can see it. And each block is an academic paper. And the distance between the blocks represents how similar those papers are to each other. And the model is basically exploring this space and finding the papers that we want. The particularly impressive thing is that this was made by a guy called Jens, who was a 14-year-old work experience intern, and I think it took him about 2.5 days. So yeah, pretty impressive. I'm kind of in awe of what people are able to do these days. I think it's about to zoom in, so let's just zoom in for a moment and I'll move on. Yeah, there we go. So you can see the green and the red popping up. That's papers that are being excluded or included. So you can find out all about this pipeline that we're building in our preprint. We're having a bit of trouble getting it published. I think it's like one of these challenges of working interdisciplinary. We've got ecologists, conservation scientists working with computer scientists. We can talk to each other in a room, but the way we write papers is really different. Like the whole conventions of writing these things is very, so we've tried a couple of places and it's kind of, the sort of, not saying this is wrong, but it kind of needs a bit of an overhaul. So we'll get there eventually, but you can check it out as a preprint if you want. In this paper, we have evaluated the performance of this pipeline in trying to recreate one of our synopses. So the amazing thing that we have with the Conservation Evidence Database is essentially a ground-truthed source of information. We've done the manual screening to make these synopses. We can then set the models to try and do the same and see how well they do. So in this exercise, we managed to get hold of 150,000 of the papers that were searched as part of the butterfly and moth synopsis. And then we set the pipeline off on those. So about 1,500 passed the initial ranking phase, all of which were in this synopsis. So it didn't, all of the papers made it through that phase. And then it correctly included 97 of the papers. So it missed just 5 out of 155 papers that were in this subset. We did get quite a few false positives. So we got about 1,300 false positives. But interestingly, we did a little bit of manual checking of these papers. And we found that about 20% of them could well meet our inclusion criteria and you could well summarize. So I think we're actually finding all the things, pretty much all the things that we found, plus some additional stuff. And I think that's a combination of a few different things, partly how less costly it is for the model to say, yeah, sure, I'll include it at title and abstract phase. And then they actually find something in the main text that you might well miss, because papers don't always tell you all the things they did in the title and abstract. Sometimes they hide things away inside the paper. So that's part of it. Part of it is that humans miss stuff as well. So humans aren't perfect at doing this stuff. So I'm going to talk now about quite a different project, but it's all well and good finding the evidence, summarizing it, assessing it, doing all this fancy stuff, making it available. But how do we actually use it to improve decision making and practice? So I want to talk a bit about the Conservation Learning Initiative. This was a project that I was involved in alongside MARVA, who were a grant-making foundation, and Foundations of Success, who are ecological consultants. This was basically driven by the MARVA Foundation, who wanted to kind of reflect and learn lessons from their 30 years of grant-making in the conservation space. The general plan was to use their portfolio of grant reports and supplemented with wider literature searches to understand the effectiveness of some quite high-level conservation strategies. So this was the team. Like I said, we spanned continents, academics, funders, consultants, all kind of working together, which was really quite good fun to be a part of. So they looked through kind of thousands of MARVA grant records and tried to pull out grants that involved implementing some kind of conservation action. And these were the 4 that kind of came out as sort of the most frequently done and with the most relevance to what we judged to be the most relevance to the wider conservation sector. I'll tell you a little bit about what we did with capacity building, which I think is quite interesting. So we used theories of change to build theories of change around the actions that we were exploring, using these results change diagrams to kind of lay out the logic by which we thought these actions could lead to beneficial outcomes for nature. So here's a sort of simplified version of our capacity building theory of change. So the first thing, you're doing your training and capacity development, you need the conditions for successful training to be in place. You need the trainers, you need the trainees, you need all the resources that you need to do it. After that, you hope or you assume that people are going to be trained, and the trained people are going to actually do the things that they were trained to do. You're going to need the appropriate conditions in place to actually apply those skills. And you're going to need skilled people to actually stay in your organizations. And the hope is that that all leads to improved practice and you get nice, positive outcomes for people and nature. But the reason for building these theories of change is because we actually want to interrogate the assumptions that we're making here. And we highlighted a few key assumptions that we wanted to test. So train people implement strategies or actions more effectively. That is something that we're assuming, and that is a key part of why we think this particular action is going to be beneficial. Trainees actually apply their skills in their ongoing work. Again, if they're not doing the things you're training them to do, then the training wasn't really effective. And then trained people stay with their organizations for at least 5 years after the training. So we've framed these assumptions as a way of kind of interrogating this theory of change, and we can then go out and find evidence to test these assumptions and see if they hold. So in doing this process, what kind of counts as evidence? Maybe we should have asked this question right at the beginning of this talk, but I think it's nice to kind of reflect on. And we use this very broad definition of evidence. So relevant data, information, knowledge, and wisdom that can be used to assess an assumption that relates to a question of interest. So really anything can be evidence, opinions, perspectives, observations. It's not just, evidence isn't just confined to the scientific literature. We were searching evidence within the MARVA domain, so in their grant reports, engaging with their grantees through questionnaires and discussions, and then we were supplementing that with data from the Conservation Evidence Database, as well as wider searches as well. And yes, you have to forgive us for the exploratory searches of Google and Google Scholar. We had, I think, 3 months of work and 4 learning topics with about 15 assumptions, each of which you probably could have done a systematic review for. So it was kind of one of those cases of like, we've got money for 3 months and we want to see something at the end of it. So we sort of did the best we could. And what we used all of these different things as evidence. So questionnaires, financial data, quotes, findings from papers, conclusions from discussion groups. And essentially what we're doing when we're gathering our evidence is gathering almost like blocks that we're going to place on a balance. We can think of evidence as these blocks, and we're going to place them on this seesaw. And on the one hand, you've got pieces of evidence that support your assumption. You've got the other pieces of evidence that refute, or those that are mixed. So we placed our blocks on the balance, but some of them will kind of, carry more weight than others. And again, this is a little similar to what we're doing with the study scoring. So we want to give more weight to some studies than others. But in this conceptualization, you can see that, the size and the placement of your blocks kind of tells you whether your assumption is supported or not. So that's the kind of conceptually how we did it. Here's what we found. So it turns out that trained people do seem to implement strategies more effectively. It suggests, though, that there can be huge variation in this. So training programs can vary from fantastically successful through to an absolute failure. And there's, I think, massive opportunities for the conservation sector to learn lessons from the training community. Should say, the nice thing about breaking your problem down in this way is that you're not simply relying on evidence from the conservation sector, because really our assumption isn't really related, say, to conservation. So we can draw on evidence from all kinds of sectors that have implemented training and understood the effectiveness. We found really good evidence that trainees apply their skills in ongoing work, but with the caveats that certain things need to be in place. So they need opportunities to use their skills. And it's really important to think through the whole training process, from before training, during training, and after training. I think, studies have found that sometimes trainees have kind of already decided before they go to the training whether they think it's going to be useful and whether they're actually going to apply the skills. So if you're going into training being like, I don't think this is going to be particularly beneficial, I'm probably never going to use it, then you are probably never going to use it. So it's really important to think about these things. And then we weren't really able to draw strong conclusions about this idea of whether trainees actually stay at their organizations. And I think there's a lot more work to do on this. I think this is an important question for conservation organizations who are cash strapped and wondering how much they should be investing in training their workforces, basically. So they don't want to be training people who then go off, join other sectors, take those skills with them. So I think we'll kind of leave it there. Just kind of ending on a bit of a shameless plug for a new paper that we've got on the evidence for evidence-based conservation. We can talk a bit more about that if people are interested, but part of what we've done is try to kind of think about when investing in evidence-based conservation is a smart thing to do, because it's not free. It takes time to do it properly. It's going to take you more time than simply making a decision based on your experience. And just to share this, which I thought was funny, we're in a kind of new age of attention, aren't we? And any engagement is good engagement. So I thought I'd share this somewhat negative engagement we had with the paper. I don't know, man. Where's the evidence of the evidence for evidence-based conservation? We've got the evidence all the way down. It always has been. So, cool. Thanks very much. I think that leaves us about 20 minutes. So we'll leave it there.
Thank you so much.